And while that is being done, let's carry it back to the lab. So that this don't have the yeah, good. It's there. It's definitely there. All right. So we're gonna press F11, switch the screen. Here we are, guys. All right. Yeah, so here you have it, guys. All right. So remember, we have the mass of the metal already, guys, at 8.9. And there's a water in the beaker. All right. So now let's see what instruction is here, because we are at stage one. Drag the metal block into the glass. All right. So and then it's a raise the water reservoir, which is this. This is the water reservoir there. All right. And then you fill it. So we fill it about 500 milliliters of water in there. Number 5 says place the beaker on the plate surface. So we're gonna place it here. That's the plate. Everybody seen that? That's a hot plate there. All right. Let's see if we can go over to the hot plate. So this is the hot plate, guys. All right. Everybody seen it? Uh, Tiffany, Kemar, Caris. All right.
Yes, sir.
All right. So let's see the instructions. All right.
Yes,
So all right, very good. So
sir.
yes, go ahead.
Sir, before you move on, my internet is oh,
So yeah, so it's recorded. All right. All right. So let's go. Let's go back to the instruction. Number 6, drag the thermometer into the beaker. So then we're going to drag the thermometer there, and it says it's going to zoom in. All right. So everybody seeing the thermometer inside the beaker? All right. With the
Yes,
block.
sir.
All right. All right then. And the next step says adjust the heating temperature by rotating the knobs. All right. So you're rotating the knob here. Let's close this. All right. So this is the knob. We're going to rotate it. All right. Rotate it to about 80 or 90. All right. So between 80 and 90, it's a. So there about 90 to 99. Let's go back to the figures here. 90 to 99, guys. That's the heating temperature. All right. So we're at number 7. All right. And then we're gonna record the value. So let's close this now and record the value. We press here to record the value. Record data. See what the data is like. And should be recorded. This is gonna say 90. And the reason with the hot plate, okay, it's actually being heated. So we have to give it some time there. All right, so this is actually simulating a real lab. You see the steam coming off there, right? All right, so it should be at 9. Yeah, so reach 90 degrees here. So we have to give it some time. It seems that it's really simulating there. Okay. All right, so they said during the all right, so while this is heating now, we must drag the calorimeter to the balance to find its mass. All right. So we're going to go back to the calorimeter, guys, and the calorimeter is over here. This is the calorimeter, or at least a part of it. All right. All right. What is seeing that? All right.
Yes, sir.
All right. So calorimeter, mass of the calorimeter is what? 45.45. All right, that's in grams. Interesting that the mass of the water wasn't taken, but let's see how that works out later on. All right, so that's okay. 45.45 for the calorimeter. All right, let's just see what the instruction says now. We're gonna write down that. It says record. So we record that. And then press record to record this value. All right. All right, so that's cool. Click on the balance now to tear it before adding water. All right, so again, we're going to click on this, bring it back to 0 now. All right, so we're going to know when this is where we're going to measure the mass of the water. So we're going to raise the water reservoir here, guys, to it. Put water in there. All right. Then the mass of the water now is actually 20.71. So we have some information here, guys. The mass of the water is 20. Mass of the metal is 8.9. Mass of the calorimeter is 45.45. All right. And we're going on to the step number 13. We're going to record this value again. So if we click record data, certainly we should get some data there. All right. Now we're at number 14 now, guys. Drag the calorimeter to place it inside the insulating jacket. All right. So the calorimeter with water, place it inside the insulator there. Let's see. All right. And then of course, notice that the metal over here is being heated to 90 degrees. So what's going to happen? So we're going to transfer this metal at 90 degrees, guys, which has some heat on it. And we're going to put it in this calorimeter. And what we expect to happen, that heat would leave the metal and go into the water in this. All right, now let's continue. All right, so they said then we're going place to cover there. All right, so then we're going to cover it now, guys, and we're taking the temperature of this. Everybody can see the temperature. All right. Let's see initial temperature of the water. And see if we can record
Yes,
this.
sir.
All right, you seeing it? Good. All right. All right, and over here, all right, so we're seeing some measurements here. This looks to be just under 95 for the water that's heated, and not the water, but this actually will be the metal. And let's record that. It says record data anyway. So we should be able to read this. All right, let's see what's happening here. So we have the data. Are we able to see the results here? Okay, there are the results, guys. All right, should be seeing the results here. All right. So again, mass of the solid, that's why I have M subscript S here. Mass of solid, in this case, the metal is copper, 8.9. This is the temperature now, and it's actually recorded the temperature of the heated water, which is where the metal is. Temperature of the solid is why I call it TS. All right, just understand what's happening here, guys. So I'm going to put it down here. Mass of metal is recorded as MS. Because the metal is a solid. TS is the temperature of the solid. So that would be initial temperature, and that's TS. All right, so we have TS there. MC, so it's actually the mass of the calorimeter. So did they answer that? Yeah, that's gonna be MC. All right. MW is the mass of the water. So it's gonna be MW there. All right, and then what we have now, TR. So that would be, okay, temperature of the reservoir. I guess that's the temperature of the water in the calorimeter. So that would be TR. And they call it the reservoir. So that's why they use R. All right. And then now, guys, we're going to get the final temperature by after we're going to move this now. This piece of metal, we're going to move it over. Let's just get this out of the way. All right. So, guys, what we're going to do here is take this piece of metal. All right. Well, you see that this object on the table here? But you see this before? This object that I'm holding up. All right. So now Remember, this is actually called a forceps or a tongue. All right, it's actually a tongue. So basically, you hold it because it's hot, and you transfer it over here. You have to do it fast too. And then we cover it. Oh, one sec. We need to go back to this table to get some results before. Well, that temperature is supposed to be increasing, guys, but we can get the results afterwards. All right, so guys, the temperature should be going up. All right, should be going up. The heat from the metal is slowly being transferred to the water in the calorimeter, and it should go up. All right, let's see what's happening here. This is number 15, and of course the temperature there. We're going to press the record button, or not quite yet. We're going to record it. Experiment has ended. All right, so it seems as if it's finished. And it's telling me to get it from Excel. But let's just complete this, guys. This is the so these are the results. All right. So when put this in the table, and remember that we just did it for copper. All right. Temperature of the water and temperature of the water. And this is initially, this has TR, that's 17.9. All right. So we are here. And then, of course, the final temperature of both of them, because the remember that the metal was placed in the water at 94, but then some of that heat would have left it, and then the temperature dropped now to 20. But the temperature of the water increased to 20. So we have to make a note of that there. Final temperature of the water is now 20.3 after the metal went in there at 94.4 degrees, guys. And that's it. Any questions here, guys?
No, sir.
All right, very relatively short experiment here. That's let me see something here. TF. All right, temperature final. All right, so there you go. There you go. All right. Now, what we're going to do, guys, is that we're going to do this for another metal. So we're going to repeat this. So we'll go back here and we're going to basically reload it. All right, put it in English and press OK. And it was going to go through the motion again. All right. All right. So we'll have information for copper. And then there's another element that we need to do, and we need to compare the two metals. All right. So, all right, we're going to use aluminum this time. As you can see, the color of the object change now. That's aluminum. All right. We're going to do the same thing again, guys, until we pull up the data. All right. So, coming again, as you can see, the aluminum right now has a mass of 2.7. It's 2.7 grams. All right. So, we're going to put that in the table. So, 2.7 grams for aluminum. And all right, and we follow the next step. So we drag it, press record. So we're gonna record that data that's finished. So the mass of the aluminum is 2.7 grams, guys. All right. So now, again, we're gonna move this into the beaker. That's the glass beaker there. And if we can get another angle here or something. No, this is not ideal at all. It probably would be above there, and just drag it there. All right. So guys, all right. So let's just go to the next step here, guys. All right. When they put what it in there, raise away and basically bring up the water level there. And then put it in there. And then of course you should be able to move it to the hot plate. All right. And then I guess we're going bring in the thermometer here. Drag the thermometer to the beaker. So I did. All right. Just trying to get the temperature of this now. Oh, okay, this is the wrong. Drag the thermometer. When I say the first one, say must place the beaker or the plate surface. Okay. I have to put it over here, so that's the problem. All right, let me zoom out then, guys, and get it in. All right, so it's over there, and we get the thermometer on it. All right, guys, and there we go. So let's zoom in, and it's actually saying 20. All right, it's under 20. All right, good. All right, important thing is that when heat this, guys, the same thing we're doing that we did for copper a while ago, but this time it's aluminum. So, and need to get this up to around 90. Yeah, all right, put it on a temperature there. Put it at 94 and see what happens. All right. Now it's going to allow it to heat. We're going to record this. All right, while that records, we'll go to the next step. All right, drag it to the balance then. All right, so when we move the calorimeter over here, take the measurement, guys, 46.29. All right, and then of course, let's move it. All right, let's go across now. We record that. All right, of course, it says record that. Click on the balance to tier it. So when again tier it down to 0, and then I'm going to put some water in there now. All right, and that's filled. Calorimeter is filled. Water. It looks to be 68 here. So it's 68. That's year before. 68. All right, so it's gonna be 68.21. All right. Next step. Record it. All right. Now, let me say, drag the calorimeter and place it inside it. So I put it in the jacket there. And then, of course, the top of it, when you cover it. All right, temperature there looks to be just above, well, looks to be above 17. But this one over here looks to be just above 95. So you can see here. We record that data and see what happens here. So recorded data. Table should be filled. Except for the final temperature. So we're gonna have to move it over now, guys. So we have some information here to put in the table. Mass of water is 68.21. And then the temperature of the water, that's in the calorimeter at the moment is 16.9. That's the initial temperature of the water in the calorimeter. All right. Now, 16.9, but we're gonna again take the heated metal. Let's close this. Take the heated metal using the forceps and put it in there quite quickly and close it. All right. Temperature, well, this temperature is going down. I don't know what's happening here. Okay, so the temperature of the object there is falling down. All right, so let's see what data is here. We're gonna press record and see what information we get. All right, setting experiment has ended. Let's see if we can download that. All right, fine. Let's just go to the table and see what's happening here, guys. All right, here it is, guys. Final result here is actually 17.5. The temperature of the metal, as you can see up top here, was 95 when it was heated. So it's 95.9. And of course, it fell to 17.5 when it was placed in the water. Any questions here, guys? All right. So this is it, we'll collect the results. It's just now to calculate now. It's just to calculate this. So we have it for copper and we have it for aluminum. All right, so we can switch back over, and there you see it. So we followed all of these instructions, all right? And this is the results we have in the table. All right, now temperature of the water equal temperature of water equal change in calorimeter here for metal. All right, so here's the
Excuse
formula.
me,
Yes, go ahead. Yes.
sir. Through the we have like we write a full up, so we write up how we calculate and how we get what answer.
I'm not hearing you clearly
So I'm
enough.
sure. Sir, yeah, hear me now.
No, your internet poor, man.
Hold on, sir.
Yeah.
Sir, hear me now.
Yeah. Exactly, but you can go ahead. Go ahead.
Sir, so like how we do like the calculation and stuff, so write up full one, sir.
Like the calculation, if I'm going to do what?
Sir, fee calculation, we write up.
Yeah, supposed to write the calculation. It's on the screen here. Let me close it.
Yeah, like working out, sir. We work out in a lab.
Yes, well, of course you must work it out in the lab. You have to show the working out, or you get the marks sheet. You not get no marks if you not show the working. So you have to show it.
Oh,
Yeah. Yeah, so this now, but remember, let's go back to the mark scheme for this lab. This lab is marked for ORR and AII. Sorry, AI. No, ORR is like the table. It's like for completing this table. All right. And of course, having the right unit. So that's done. The analysis now and interpretation now is the calculations that you're being marked for, as well as answering the discussion questions. All right. So there you go. Heat lost by metal is equal to heat gained by the water and calorimeter. So we have to get the results to put in there. All right. The mass of the metal, well, for the first one, as we notice that it's metal 1 and metal 2. So metal 1 would have been copper. Let's put copper in bracket. All right. And then, of course, for metal 2, it would be aluminum. And then we have some results here. All right. Now, we're going to try and put in the numbers. So that help you guys to calculate what's happening here. I'm not quite sure where they will get the data from, the calorimeter. Do you have anything for the calorimeter? In terms of the specific heat capacity of it. So then, okay, so all right, let's see how this works out. When what we have is the mass of the metal. You see, mm is the mass of the metal, guys. And then cm is the specific heat capacity of the metal. C is a symbol for specific heat capacity. All right, of course, delta T or triangle T here is the change in the temperature. So let's just put in some results there and see what it looks like. All right, mass of the metal, for the copper, mass of the metal is 8.9. So M here is going to be 8.9. So when I'm multiplying 8.9 by the specific heat capacity of the metal, which that's what we're trying to find. So We'll write that back. However, the temperature change of the metal was, check this out, it's actually going to be initial temperature of the metal, which is 90, 4.4. And when you subtract the final temperature of the metal, in fact, what it did say, it says the final temperature minus the initial temperature. So let's just change that one. All right. So yeah, guys, remember that delta T is equal to the final temperature minus initial temperature. There, this is just a rule here. And final temperature must come first. So in this case, final temperature of the metal is the same as the final temperature of the water. Here it is 20. All right. And it's going to be taken away 94 because the metal went into the water at 94 degrees Celsius. And this is what we're going to have. So let's let's group this together, guys, and see. All right, there we go. It's come off. If this copy to no that copy. All right. So anyway, so we have this, guys. So we finish this part. What we just work out is the heat lost by the metal, or at least we partially work it out. All right. Remember, to find the heat lost by the metal, it's mass times the specific heat capacity times the change in temperature, and that will give us the answer there. All right. Now let's look at the water now, because them say the heat lost by the metal is equal to the heat gained by the water and calorimeter. All right. So what happens here is that mass of the water, go back to the table, mass of the water for the copper would have been 20.71. So it's going to be 20.71. 20.71 times the specific heat capacity of water. And you should know that. Let's confirm that and the table. I don't see they have any table for this now. All right, let's close this. Something. There's no PDF for this. I want to see if there's any information that could help us with this lab. Okay. All right. Yeah. All right. There it is. Let's go. When I can't go over. All right. I don't know this and show you something. All right. I will. I'll come out for this here. F11. All right. No problems here, guys. All right, let me show you something because there's some information that I didn't give you. So I'm gonna share it over here. So to work out this, guys, we will need we should have gotten a data sheet, because we don't know the specific heat capacity of water or for the calorimeter, and it's needed. So that we're gonna get it from here. All right, and here it is. Here's the information there. Let me show you how to calculate it. So
Idiot.
I group that.
Hear me? Yes, sir. Your PC said if somebody
Let's zoom in.
when I say mush up.
All right, so here we go, guys. This is 4,186. All right, that's for the specific heat capacity of the water, and that's written as CW. We can copy that 4186. All right, so make we move that over. So for the CW here, which is the specific heat capacity of the water, it's 4186. All right, 4,186. All right, and temperature change of the water, final temperature of the water is 20. Initially, it was 17. So it's going to be 20.3 minus 17.9. All right. Now, so that's the water. Now, what about the calorimeter? The water and the calorimeter are seen as one object because, you know, some of the heat going to go to the calorimeter as well. So we have to find the mass of the calorimeter, which was given here as 45.47. So 45.45 rather. And that will be multiplied here. So that's MC. Then you have CC, specific heat capacity of the calorimeter. And let's go back to the table for that one. That one is here. It's over here actually. If you can see it here, it's actually 387. That's for CC. So that's 387, guys. So 387. And of course, we're multiplying that by the temperature change, which is the same. Calorimeter and the water going to be at the same temperature. So so when you use whatever we have for water here. So it's going to go 23 as well. It's going 20.3 rather, minus 17.9. And then there you go. So yeah, you guys should be able to finish this, you know. I mean, this is just showing how you're going to set out. So it's gonna be
This good, sir. Um,
yeah.
sir, sir, one way to get 45 or 40,186, sir. That will be for the C.
Yeah. All right. So let me group them together for you. Tiffany. Let me see some. All right. So all of this here, all of this is here. See that?
Yeah.
As a matter of fact, let me go back here. So all of this is on the left hand side. Heat loss by the metal. All right.
Yes, sir.
Left hand side. Right hand side now. Get a different color now.
Already
Right. So this part now, all of this what I put in green is for the water. All right, it's for the water. So let me just cut it off right here. So it's gonna be all of this here, so it's for the water. All right, all of this here, so it's for the water. All right, so the green part is for the water. All right. And then of course, whatever leave out now is going to be the calorimeter. Yes, yeah. Can I use one next color for that? Use purple or something like that. Yeah, the calorimeter now is all of this. All I hear so is the calorimeter. See, so let's make sure you focus on those. So that means to say no for the and let's keep on. I keep using the color scheme feet, work it out. So now that means you know the heat lost by the metal, you're not going to have any, you can't work this out fully because this is what you're going to have one unknown in there, which is the CM, specific heat capacity, which is what you're trying to find. So that's the unknown. However, you can work out everything else. On the right hand side, we have the water and we have the calorimeter. For the water, it's going to be 20.71 times 4,186 times the difference between this number in here. So if we were to go ahead and do that, you should get this figure here. Let me just see here. All right, so it's going to be 20 minus 17.9, and that looks to be that's at 2.4. It's going to be 2.4 here, guys. And then 4,186 times 20.71. You're definitely going to work out that part. All right, so what you're going to have here is a case 2.4. And if you should bring up the calculator here, and it would be about 20.71. Let's go back here and fix it. It's going to be 20.71, right, times 4,186, 4,186 times, all right, and let's see what happens here. It's going to be times 2.4. And you get 20. All right, it's actually 208,060.944, guys. That's our answer here. And this is going to be written in green. This is for the water. All right, so let's go over that figure again. So the figure is 208,000. All right. In fact, we could just copy out this too. And I go through that, all of that trouble. We just copy this number. Just copy it. All right, let's get that out of the video. Just copy that number here. It could be pasted that text or something. It's actually there, but I want it right here. I want it right here. All right, there you go. I can just drag in this back out. So this is the number we get, guys. So I don't know, put that in a green. There. And then we'll just drop it in here. So we have this now for the water. All right. That's for the water. I don't know why so big. Probably can make this smaller. 18 carried down to 14. Yeah, font too big. All right, right there. All right, so this will find out everything for the water. All right, now for the calorimeter now. See the numbers in here. 45.45 times 387 times the same. This is going to be 2.4 again because it's the same as the water. So let's change this to red. And this will be our 2.4. Multiply that by 387 and get a result there. In fact, let's save this in case like go again because we don't want to lose all of this. All right, and so this is all right, and it's going to be completed. All right. All right, there we go. So let's fix up that now. All right, so it's gonna be 2.4, guys, times 387. Put that in the calculator. And let's clear everything. No, I don't think I need that again. Go again now. So it's 2.4, guys. 2.4 times 387 times 45.45. And that number gives us 42,213.96. All right, we can easily just copy this number and put it into the over here. All right, this is now different. Yeah, put it down here so guys. All right. I'm gonna change this font. I want it to be probably put it in a red. All right, font at about 14. I'm going to drop it right here. So for the colorimeter, it's this. So when you add them, let's add up these numbers and these two numbers together. So that I'll give you We'll get a number here, so. So remember, we're dealing with the right hand side first. Add everything that we get for the water to what we get for the calorimeter. And so the heat lost by the metal would be equal to that. All right. That's it. That's the important thing to remember. All right. So if we go back to the calculator now, we add this.
So we get
How much you get?
250,000. Wait, I like 1, 2, 3, 4, 5, 6.
Okay. Well, we figure that out. Let me just clear everything. Right there. All right. Plus. Where is that? That's on the screen. Sure. All right. So that we have here. And we're gonna add 42, 213.96. 250. .904. Let's copy that. Get the answer here, guys. All right, so she's the answer. And pay attention to these figures here when you save this. All right, what we can do with this now? If you let me see if I can zoom out and yeah, I'm supposed to have some space here, someone. All right, we're gonna drop this further down. Yeah, I'm gonna scroll it down here, man. And then the triangle can. All right, there you go. So we have space can work now. So we are simplify this now. All I will just get here, so is gonna be equal to let's zoom in so we get closer to the problem. All right, so all I will just do here is equal to that. Yeah, basically I'm gonna say 8.9. And all right, we'll use since we start use black already. Okay, let's continue with black for the left hand side. All right, keep the color code there. All right, so it's gonna be for the metal now, it's gonna be 8.9 times cm times this number now. It's gonna be 20 minus 94. Actually, it's gonna be 20 minus 94. It's going to give you a negative number. All right, so you're definitely going to get a negative number there. And let's find out what that is. It's gonna be 20.3, and we're gonna take away 94.4. And there we have it. It's going to be 74.1. All right, so it's 74.1. And but it's going to be negative. So I have to remember that, because heat loss mean negative, taken away. All right. So what we're gonna do here is gonna be equal to 250. So what is when transpose CM now will now be equal to 250,274.904 divided by it's gonna be 8.9 times minus 74.1. So that will give us the answer here. And 8.9 times 74.1. All right, that's the answer we're looking for. All right, 8.9 times that, we're going to get 659. So it's negative 659. So 250. Okay, all right. So it's gonna be negative 659. Let's look at the decimal point values. See if we have them. 0.49. And of course, we're going to put back the same 250 that we get. All right, from here. In fact, I already did write it back, but we can just move it here. All right, so whatever I get for this answer is the answer. We'll finish after this, finish for copper after this. So, just probably, should we doing it online, it might be a bit more challenging, but I mean, there it is. All right, so what we're gonna do now is divide this number by, it's gonna be 6. All right, it's gonna be 659.49. Interesting. That's kind of right. That's kind of right. Right, no? Let's copy all that number. Get this thing in. 250, 274. All right, so there you go. I think we have numbers them right. 250, 274.94. Yeah, I get 379. This is the answer. 379 is the answer, guys. 379. We have to remember the decimal places. Too many decimal places here. We have to go round this off. So
So the negative.
yeah, definitely negative. Because the negative is here, but we just want to get the number right. Can put the negative sign afterwards. So it's actually gonna be approximately 380. And yeah, approximately 380. Negative 380. But for heat capacity, the sign is not important. So we could ignore it here. The minus just tells you that it was heat loss from it. But the negative is, when it comes to heat capacity, it's not important. The sign is not important because it's always positive in that case. All right, so then it's 380 is the answer for copper. All right, now we have to do the same thing for aluminum, which, all right, you guys can do that. And then here are the questions to answer. All right, discuss relationship between heat and temperature, and those things. All right. Yeah, you write the results. You going
Sir, so for this lab, no platinum graphs, sir.
no platinum graph, no.
Good.
Yeah. Yeah. So this that this was calculation and here. So you have to calculate this. So this is what you guys going to know. You're going to have to do it the same thing what I show you what I did for copper. You're going to have to do it for aluminum. Use the information and get the answer for aluminum and answer these discussion questions. All right.
Sir, but this some was, sir, in the equation, sir. Sir, you need go on something again to put in if you think CW and CC, sir. I'm not sure. So I see I'm going to use box, sir, and all.
Yeah, man. Same thing I use back. So all right, let me write it down here. For CC, it's gonna be 387. All right, and then for CW it's gonna be 4186. Yeah. All right. So that's constant. All right. Any questions here?
No, sir.
All right. Let's end this as PDF. All right. So I'm saying that in the group. Why this thing close?
I'm laptop.
Oh, I forgot to put the date on it. All right, one day. Today are the 30 for 30, no? 30 at the 3. All right. Let's see if this again. Folder, you know, physics folder. All right, and so we have that then. All right. All right, and what I'm going to know, I'm going to send it in the. I send this in the classroom, so you can get it and look at it, finish it. All right, grade 12. Okay, yeah, here it is. All right, so add the file there, guys, and then edit that. Put the file there.
Sir, we're saying something.
Yeah, I send in it. I send in the or just do in the classroom. So you can download it and finish it. Or if you did screenshot or internet problem. All right. So let's see what
Sir.
then.